Hi everyone. So today we're going to work on an 820-00165. That's an A1466 MacBook Air from 2017. It's this device right here. And as you cannot see, it's on. So it's turned on, but it has an image, but it has no backlight. Let me show you. I'm gonna shine my iPhone light through the back. There you go, and show you under the microscope. There you go. So there is an image, but backlight is not present. We're gonna try to diagnose it and fix it. So most of the times these issues can be fixed. Or let's say there's never been a case where I was not able to fix it. So we're going to take a look at the schematic to see how we're going to approach the problem. So let's see, schematic is here. Backlight is page, I remember it's page 66. 56, sorry, yeah, page 56. So this is the backlight circuit. This is the backlight IC. The backlight power supply is PP HV SOSW LCD backlight, and they say somewhere that it should be 50 volt. That this is not the correct value. It's usually when it's working, it's around 25 to 28 volts. And if it's not working, it's going to be way below that. The first thing that I want to do in these cases is to measure the value of the backlight output. So here, let's try and locate it. For example, it's going to be here. Oops, sorry. And let's go under the microscope and measure it. Hopefully you can see there. Okay. So backlight output is here, 8.5 volts. So of course this is way below 26 volts, so this explains why we have no backlight. Backlight fuse is here, and we're gonna measure, no, we're not going to measure it. Actually, we don't need to measure it because we have 8.6 volt here. I'm gonna explain it on the schematic. So let's switch views here. So here, PPHV SOSW LCD backlight, I measure 8.6 volts. If we go back all the way, assume that this chip is not doing anything. If it's not doing anything, then this here, so it's diode, coil, MOSFET. So assuming the MOSFET works, it's closed. And so this line to this line and this line are connected. This is our backlight fuse. And here we have PP bus G3 hot. So if the chip is not working but the MOSFET is closed and the inductor is working and the diode is working, we should have basically PP bus here. And this is what we measure. PP bus is 8.6 on this machine. Here we measure 8.5. This is okay because the diode usually taxes something like 150 millivolts. So the fact that we measured 8.5 volt here at backlight output means that this is okay, this is okay, this is okay, this is okay, and all the part here that controls this MOSFET is also okay. But since we measure 8.6 volt instead of 25 or 26 volts, this tells us that this chip is not working. So we're going to try and figure out why by looking at its working conditions. So in order to work, it has to be powered by PP5 VSO, PP3 V3 SO, and these are the only power requirements. We can be certain that these are present for the simple reason that they are absolutely required for the machine to turn on. Since the machine turns on, PP5 VSO is here, PP3 V3 SO is here. Then it has to get its enable signal. Enable signal is here BKL enable, backlight enable, which is PPVin SOSW LCD backlight going through a voltage divider. What is PPVin SOSW LCD backlight? Well, if you look up here, it's this. So basically it's PP bus. So this here should be 8.6 volts, but because we have a voltage divider with like 200 kilo ohms and 100 kilo ohms, just making here quick computation of the voltage divider formula, we should have 100 divided by 300, so that's 1/3, times 8.6. So, okay, so that's 2.86, so basically 2.9 volts. So here at backlight enable, we should have 2.9 volts. If this is not the value that we get, then this would explain why the chip is not turning on. So this is the next thing that we want to check, whether backlight enable is here. This is, unfortunately, these resistors here are on the other side of the board. So we are gonna have to get the board out in order to measure this. However, well, yeah, if you think about it, in order to measure this, so you need to have the machine turned on with the screen connected and the display present, the image present, in order to have this to expect the chip to turn on. This is one of the conditions. So, but we need to look at it at the other side of the board, which means we need to take the board out, connect it to the display, flip it over, and then connect it to power and make our measurements. This is kind of tricky. I mean, there are a lot of moving parts. The board is not secure. It's outside of the housing. So the way I think about it is I don't really need to measure PPV, the backlight enable signal. I don't really need to measure because I know that PPV and SOSW LCD backlight is present because it's this, which is the same as this, which is 8.5 volts. Therefore, all I have to make sure of is that these resistors are okay. If the resistors are okay, because this guy here is present, then automatically this will be 2.9 volts when the machine is turned on, with display turned on, etc. Therefore, I'm just going to measure these resistors and make sure they're okay. This will guarantee that backlight enable is present without having to turn on the machine with the board flipped over and everything. So this is what I'm going to do. I'm going to take the board out and we'll meet again when it's done. Okay, it's done. The board is out. We're gonna take a look at it. So this is the backlight IC. Okay, it's a bit dirty around here, but nothing suspicious. I'm gonna clean first, remove all the dust. There you go. And as I said, I'm just going to make sure that these resistors are okay. So who are they? R7731 is here. And R715 is here. So this one should be 200 kilo ohms, and this one should be 100 kilo ohms. So it's these two guys. So multimeter in resistance mode. So the annoying thing about the resistance mode is that it takes a lot of time to stabilize, but the point is that I'm getting a value which is not open line, which means that the resistor is probably okay. And here also I'm getting a value that's increasing, and that's getting closer and closer to 100 kilo ohms. So this resistor is probably good. So this guarantees that backlight enabled signal arrives to the backlight IC. And therefore, we know that when the machine is working, the chip is getting power and is getting its enabled signal, but backlight is not turning on. So this is a good enough reason for us to replace the chip, because it could be bad. And the only way to make sure is to replace it. So let's do this. Now, chip is removed. Clean the pads, refresh the solder with low melt. Clean up. Okay. I do have one that's already been reballed. I pulled it from a donor board before, and just in case I would need it and to save some time. The only problem is that I'm not sure it works because it comes from a donor board, so that's life. Before putting it back, there's something that needs to be checked, because it is also a cause of failure of the backlight circuit. It's that pin. That's the here, as you can see, PPV out SW LCD backlight feedback. It's this line here. It's the feedback line, and it happens that many times, very often, for some reason, this line gets cut internally. That's inside the board. there is no continuity between this line and the pad under the backlight IC. So I want to check this. Theoretically, I need to check continuity between here and here on the other side of the board. That is, let me switch views. So, sorry, you missed it. So theoretically, I need to check continuity between this pad here and this here on the other side of the board. But as you can imagine, it's pretty annoying to put a probe on one side of the board and another probe on the other side, seeing that these things are so tiny. So a trick I have is, so this is here, this is the XW something. The other side of here is this PPHV SOSW LCD backlight. So that's a backlight output. And it turns out that we do have a test point here on the same side of the board as the backlight IC. So all I want to do is test continuity between here and here, just to make sure that the feedback line is not broken. There you go. So I do have continuity. So there is no need to fix this. Therefore, I'm just going to replace the backlight IC directly. And hopefully the one I pulled from the donor board is working. Flux. New IC. Can't remember the orientation. I believe pin 1 is on the top right. Yes, that's it. So check. Okay. Chip has been replaced. Let's clean up. Put the board back in the housing and check whether it works. See you in a bit. The machine has been put back together. We can try it, but first there's a point that could be made, being that maybe it's risky to still try using this display, because maybe the display itself was faulty. Maybe there was a short on backlight output inside the display, which caused the problem on the motherboard. That's a possibility, and it would definitely, if there were a short on backlight output inside the display, it would definitely cause issues on the board. At the very least, the fuse would blow, and certainly the chip would also die if the fuse took some time to blow. So it is a good point. However, I'm not worried about that, because when we tested backlight output, when backlight was not working, when we tested backlight output, we had 8.5 volts with the display connected. Therefore, there cannot be a short on backlight output inside the display. and I'm not worried about damaging the board with this display. So now let's test. Hopla. It works. So it means that we're lucky. The chip that we pulled off the donor board was working, which is a good thing. But we're never sure with these things. And that's another MacBook that's been made great again. So thank you all for watching, and see you next time. Hopefully you learned something. Bye-bye.